One of the additional features we can make use of in our patterns are guards. Guards allow us to add a Boolean condition to a pattern. This makes it so that for a code branch to run, the pattern needs to match and the guard needs to evaluate to be true. You can think of guards as a convenient alternative syntax for if-then-else expressions. Let's see what I mean with an example. Here, we are using an if-then-else expression to conditionally return a different string. Now let's see the same example, but this time defined using guards. I've called this function describe with the G, indicating that we are using guards. Now there is some new syntax here, but nothing too complicated. Let's go through it together. The initial pattern for both functions is exactly the same. We use an as pattern to define P to represent the whole person and then deconstruct the values within the person. But then, instead of giving an equal sign, we give a sequence of guards. A guard begins with a pipe symbol, then it requires an expression which will evaluate to a Boolean, either true or false. Then we can provide the function body which will run in case the expression evaluates to true. For the second guard in the sequence, we use the word otherwise. Otherwise is an alias for true, so it will always match. So this is like the else block in the previous function definition. In this example, we only have 2 guards in our sequence, but you can have as many as you like. As with patterns, guards are evaluated from top to bottom, and the first that evaluates to true will result in a successful match. Since otherwise will always result true, it should always be the last guard in the sequence. Certain style guides for Haskell state that you should prefer guards over if-then-else, where possible. This is because they argue that guards lead to more readable code. I tend to agree. One of the things you need to be aware of when using guards relates to whitespace. Make sure that your guards are all indented at the same level. If you don't follow this advice, you may get a parse error because you are violating Haskell's whitespace rules. That's it for guards. Simple enough, really. Let's take a minute to do an exercise. It is your job to write a function called sign, which takes in any int and returns an int. The sign function should return a 1 if the int passed in is positive. It should return 0 if the int passed in is 0, and it should return -1 if the int passed in is negative. And you should write your logic using guards. Okay, pause the video for a few minutes and try to write the function. Then I'll go through the answer with you. That shouldn't have been too hard. It wasn't a trick question or anything. Here is the answer I wrote. We have one binding with 3 guard clauses, one for each row in the table. We evaluate our conditions in our guard and then return either 1, 0 or -1 as needed. Guards are a nice convenient syntax to use, and we will be making use of them throughout the rest of the course. This video is a clip from a longer video for beginners starting with Haskell. Check that out if you would like to see all of the content. Also check out the entire Introduction to Functional Programming with Haskell course on the Learn channel. See you next time.